more algebra revision. We're going to look at span and brackets, simplifying expressions, because there was some of those in the test you had at the beginning. Factorising, very important, the laws of indices. Okay, we touched on it a little bit last week, but we're going to make sure we got that cracked this week, hopefully. Solving single variable equations, and one that seems to be a very sticky thing for a lot of students, that's transposing formula, so rearranging a formula from one form to another. Alright, so we get as much of that covered this week as we possibly can. There will be questions in the handout where you might not get all of those done during the time I give you in class, so there's always more practice for you to have a go at. They all come from the Bird book anyway. Maybe not the higher one, I might have got some of them from the other version, but they're in that same vein where the answer is in the square brackets. So I think on page 9 of your handout there's a drill. If you can have a go at that, 2 or 3 minutes, okay, it's related to the topics that we're going to cover today, and then we'll go through some examples. Point to make is this side here with that number. Yeah, so when you do your multiplication, that's 6 times 9 is 7. Because you need to be careful when you get a minus sign as well. Yeah. So just watch that. The sign goes with the coefficient and the variable. What about factorising? What outside the brackets? Brackets. Pilots. You can take x squared out of the bracket. You can make this term here 5 is good. 5 is common multiple of the two coefficients. Okay. And x squared is common. Then put your brackets and have a single x there minus 5. Both answers are right, and depending on purpose, might decide what you actually take outside the brackets. Okay? But that, so you're not wrong, but there was another factor in there that the purpose might be just to take the x terms out and not the coefficients, or vice versa. Alright? When you're working on a particular problem. What about solving 3x plus 2 is equal to 14? Pilot. Yep. So you can do 3x is equal to 14 minus 2, which is 12. And then divide by 3, so x is equal to 12 over 3, which is subtracted 2 from both sides, a little bit more about that shortly, and then divide by 3. What about solving this one? X is equal to 3 plus 14 plus 2. Yeah, so you've brought all the number terms, the additions and subtractions together. What you've effectively done is added 2 to both sides. Effectively shifted that 2. And if you noticed here, we're working in reverse BODMAS. We're adding and subtraction to move first, and then the division comes afterwards. Right. So that's 7x is equal to 19. Yeah. And then you do divide both sides by 7. So x is equal to 19 over 7. Alright. And as they're both prime numbers, that's left as a fraction. Yeah, because I would think that probably fills your calculator up with decimal places. Okay. What about making R the subject of this formula here? I'll do it down here. A is equal to pi R squared. That's the first thing you're going to do. If you square root A now, yeah, you've got to square root all of that. What? After you've done the square rooting? Okay, yeah. Remember what we've got. Right, and I said we have to work in reverse. So we've got no addition and subtract, but we've got division multiply in terms of this pi times R squared. Alright, so starting again, we've got A is equal to pi times R squared. Alright, it's no addition and subtraction, but we have got division multiplication, so we've got to do that first. We've got to break this multiplication here by dividing both sides by pi. Yeah? So I'm going to write that there, blue. Divide both sides by pi. And then what that means is those two pi's cancel out. Eventually I won't be doing this, that cancels that bit, because you'll get used to it. But at this moment in time, so you can see where it comes from, we have A over pi is equal to R squared. Now what do we do? Now square root, because we've done that, and we're in indices. Yep. Because as you'll see soon, square root can be written as an indices as well. So we square root both sides. So we do this and this. And if you square root a square, what happens? They cancel. Yeah? Square root is the opposite action of square root. So our final answer is R is equal to the square root of all of A over pi. As you ought to know, that the original formula, A is equal to pi R squared, is the area of formula for the area of the circle. If you know the area, want to find the radius, you need to be able to rearrange to that. Alright. What about these two? x to the 5 times x to the minus 3. How'd you get that? Yeah, if you're multiplying, you add the indices. So it's x to the power of 5 plus minus 3. 5 plus minus 3 is 2, so it's x to the 2. Yep. And if you're doing division with indices, what's the answer to this one? Yeah, that's y is equal to, y to the 3 minus 4, which is y to the 7. Because the two negatives are plus. Right? You're all reasonably happy with that? Yeah? Expand brackets and simplify this expression. So, what we have to do, we've already been through it a little bit, but we multiply everything in bracket 1 by everything bracket 2. Well, we've got two sets of brackets, or indeed more. That's what we have to do. So we have to go, we've got A plus B in one set of brackets, we've got A plus 2B in the other. We do A times A squared. Yeah. A times 2B is plus 2AB. Then we do B times A Right, I'm being consistent and writing them all in alphabetical order, and then we do B times 2B is 2B squared. When we've done that, we can then collect like terms. And it's usual to have, whereas a polynomial with powers in, it's usually usual to have the highest powers to the left. So we'd, and alphabetical order as well. So we'd write this as A squared plus B squared. We can bring together the 2AB and the 1AB into so that's multiplying out the brackets in that expression. It's called an expression that has got no equal sign. Yeah, it's not a formula or an equation because there's no equal sign. It's just an expression, so it's 1/2 of an equation, if you like. Yeah. So we'll do problems where we need to multiply out brackets, the same as we'll do problems where we need to factorise and put things in brackets. But that's the process. Multiply everything in one bracket by everything in the other bracket, taking care with negative signs. Because there's a common way to make a mistake is to not get the signs of the numbers right. Okay. So that's multiplying out brackets. Any questions, guys? No? What would you do? Actually, I've got a question for you. What would you do if you had a third bracket? Which two? Oh, sorry. Yeah. Spotted my deliberate mistake. Corley, you have? No, you should all say, because I'm testing something in the eye. Alright, what would we do if we had a third bracket there? Yeah, you'd multiply out the two brackets and then take the answer with the other bracketed term and multiply again everything in one bracket by everything in the other. Alright, it will become quite long, so that's what you would do. Alright? Okay, how do we factorise? What can we factorise in that equation? One term at a time. So we can factorise 2, yeah, we can go 2 brackets 2 squared plus 4 q. Oh yeah, no, N took q out yet. Yeah, then you can take, now you can also take q out, yeah? That's what you're saying. Yeah, so you can go 2q, q plus 4. Yeah. And like I've said before, there might be a reason why you just want to take the q out or just want to take the 2 out, depending on what you're trying to do when you've actually got a problem. Because again, this is an expression and not an equation at this stage. Alright? Yeah. Sometimes there's two different things that you can factorise, but you can't factorise both of them. So again, there might be two variables and I could factorise q or I could factorise n, but the way the expression is, I can't get both of them outside brackets because they don't match. Yeah. Everybody reasonably happy with factorisation? Okay, let's have a look at this problem. How would we subtract? You've got that one in your notes because I took some bits out, I think. Yeah, you have got it, yeah. How would we subtract 2x plus 3y minus 4z from x minus 2y? So we've got 2x going to subtract from x minus 2y plus 5z. We're going to take away from that 2x plus 3y minus 4z. And that's the easiest way to do it, term by term. Yeah, so put one term, the term that you're going to subtract from at the top, or the expression I should say at the top, and the expression you're going to subtract from it underneath, and then you just do it row wise. So x minus 2x is x minus 2y minus 3y is minus plus, so it's minus 5y. And then 5z, take away minus 4z. Just write it out here. 5z minus 4z. Okay, so careful with negative, positive, negative signs. Very easy to get it wrong. Hurry. Including me. So watch out. I make mistakes too. Right. Everyone happy with that? Addition of expressions with variables. Alright. Simplify 2p divided by 8pq. Very unusual in engineering to see that kind of divisions aren't used. How better could we write that? Where the 4p squared plus q come from? The engineering one, scientific like that, 2p over 8pq. Now what can we do? There is no square. We're not doing this one, doing that one. Yeah. 2p over 8pq. Yeah. So somebody said p's cancel out. Equal 2 over 8q. Anything else? Yeah, we can both of those numbers are divisible by 2, so we can divide top by 2. That doesn't become nothing. So many people make that mistake. Yeah, so it's 1 over 4q. Right, everybody follow that? Yeah. What about 2p squared over 8pq? Well, again, that and that can be made into, so it becomes p squared over 4pq. What else cancels? If I divide p squared by p, which is effectively p to the power 1, any number to the power 1 is itself. That's how we can write it. Is that not p to the 2 minus 1? Yeah. So on the top here, we can have p, that cancels, and the whole p down the bottom cancels as well. p squared divided by p, just leave p at the top. And that is all follow that? Yeah, but when effectively what I'm doing here, this bit, is dividing the top and bottom by p. Yeah. Here, I'm dividing the number 2 by itself. 2 divided by 2, 1. But it's quite a common mistake for that to be the top of that fraction just to disappear. Be careful of that. Right, because it doesn't. 10 divided by 10 is 1, 100 divided by 100 is 1. That 1 must stay. Yeah. This bit is here. Just let me write that out in a slightly different way. We've got p divided by 4pt. And what we're doing is we're dividing the top and the bottom by p. That's the process. So, that top of p squared was. So, what effectively happens cancellation-wise is that p, away that square sign, yeah, and that p takes away that p again. So it equals p over 4. Follow? Yeah? Alright. Everybody happy with that? No. So, simplify a to the power 3 b squared c times ab cubed times c to the 5. What can we do? They're all multiplied. These 3 terms multiply together. Do 2. No addition. Have you got that one? Yeah. Well, we got like terms in here. Yeah. We've got 2 like terms in C. So we can have C times C to the 5 is 6. Any other like terms? Where's A to the 4? That's A times B. So you can treat that A as being on its own. So you can do A cubed times A is 4. And B squared times B cubed is multiply b to the 5 times 66. Yeah? Okay. Chapter 1, sections 1.1 to 1.3, further examples of basic algebra. Alright, you're going to get some practice in class, but also spend some time just practicing a bit so that you become comfortable with it. Okay. Have you got that page in your notes? Yeah. Right. How are we doing for time? Have a little while, have a go at some of those. Okay, I'm only going to spend about 5 minutes or so, and then the rest of them you can have as further practice. But these answers here are what you should get, okay, as a final answer.